Welcome to Jennifer Chemistry Official, where we make chemistry very friendly to all our learners. Today I want us to check on common questions on isotopes and make sure that you are following on, and again make sure that you're writing something in your notebook for the reason that in the near future you might require the same notes. So to begin with, we have the meaning of the term isotopes. So remember, for isotopes, we say that they are atoms of the same element with the same atomic number but different mass numbers. So let us write atoms of the same element with the same atomic number but different mass numbers. So there are those keywords that I want us to check on, those ones that you must include. To begin with, the word atoms should be as it is in plural, not just an atom. Atoms is the correct word. And these atoms are of the same element. They have the same atomic number, not atomic numbers. Atomic number. It is just one atomic number, only that it is repeated to the different isotopes. And they have different mass numbers. There you must put an S. Let me give an example of the radium isotopes that are in question 2. If you can see well, we have radium 7 and radium 6, these two. We have radium 7 and radium 6. Check on the chemical symbols that are in that question. In both, we have Li. Li is the chemical symbol for radium, meaning that these are two isotopes of radium. If you check on the number below, the one that is at the bottom, we call it the atomic number. It is number 3, and it is the same for both. That is what we are calling the atomic number, which should be similar for both isotopes. Because in our definition for the term isotopes, atomic number is said to be the same. So 3 for lithium. And if in case you have forgotten about how we determine atomic numbers, recall what we had in our previous lesson. And if you are new here, there are those videos for lessons that we did yesterday and backwards. Make sure that you check on them. And there you will learn that radium, among the first 20 elements, it is usually number 3. And being number 3, that is actually the atomic number for lithium. And that is what is put there as 3. If you check on 7 and 6, those are the mass numbers. And in our meaning for the term isotopes, we say that mass numbers are different. So that is why we have them in plural, because they are different, meaning we have different numbers that are used there. On to our question 2, we are told to determine the number of neutrons in the two isotopes. There we must begin by writing the meaning of, not the meaning, but the formula that we use when we are calculating the number of neutrons. So let us write together. We say that number of neutrons is equals to mass number minus atomic number. So number of neutrons is equals to mass number minus atomic number. So with that formula, we are able to go on with the question. Remember, for the two isotopes of lithium, I have just explained that the number that is put on top here, these two are the mass numbers and they are different. These two below here are the atomic numbers. So everything that you require in the question is provided. We have the mass number and you have the atomic number. And because the question is on determining the number of neutrons in the two isotopes, meaning we must have the number of neutrons for both. So let us begin with lithium-7. We say from the formula, the number of neutrons will be got from the D7, which is mass number, minus 3, which is the atomic number, and so the answer is that we have 4 neutrons for lithium-7. For lithium-6, we have the mass number, which is 6, minus 3, which is the atomic number, so there we have 3 neutrons. We have 3 neutrons. Question 3 is asking us if the relative atomic mass of lithium is 6.94, which of the two isotopes is the most abundant? With the most abundant means the one that is most common and is found in higher levels than the other. So when you check on the relative atomic mass, which is 6.94, for you to determine which of the two isotopes, either lithium-7 or lithium-6, the one that is the most abundant, that is found in a bigger percentage, you compare the relative atomic mass with the mass numbers, and then you confirm which of the mass numbers is near the relative atomic mass, or rather near the value for the relative atomic mass. If you check on the first one, lithium-7, it has 7 as the mass number. When you check on the relative atomic mass, it is 6.94. If you are to round off 6.94 to the nearest whole number, it will become 7. So that is to tell you that lithium-7 is the most abundant isotope. So in the future, when you get such a question, you compare the relative atomic mass provided for you, then you check on the mass numbers for the different isotopes, and then you ask yourself, if, for example, the relative atomic mass is in terms of a number with a decimal point, you ask yourself, should you round it off to the nearest whole number? What mass number provided will be near it? So in our case, the answer to this question is that the most abundant isotope is lithium-7. So you write it as that. So we go to the reason. The reason is that the relative atomic mass, which is 6.94, is closer to the mass number of the most abundant isotopes. So that is the secret to getting that question correct, that the relative atomic mass is usually closer to the mass number of the most abundant isotope. So I hope you're writing. These are very, very important points for you to take note of. So I still have prepared more questions, so keep it right here. Next, we have this question that says lithium has two isotopes with mass number 6 and 7. If the relative atomic mass is 6.94, determine the percentage relative abundance of each isotope. So before we go to the calculation, there is this interpretation that we can do first. So to begin with, we say there are two isotopes of lithium. We have lithium 6, we write the 6 at the top, and we also have lithium 7. we also write 7 at the top. Down here, we are supposed to have the atomic numbers. If you consider the first 20 elements, lithium is number 3 from hydrogen, from the top. So being number 3, that means it has atomic number 3. So we write the 3 down here. That is the place where atomic numbers are written down here, and the 2 are the same. Then the mass numbers at the top. From there, from the question, we can see that whatever we are being asked to calculate is the percentage relative abundance. So we begin by writing the formula that is used while we are calculating the relative atomic mass. We write it in initial form RAM. So we say that we have the mass number of isotope 1, mass number of isotope 1, multiplied by the relative abundance. Put it into bracket. Then you add to mass number of isotope 2 multiplied by the relative abundance. Again, you put that one into bracket, and then all of them together divided by 100. Let me write this one in full. Relative abundance. So that is the formula. So mass number of isotope 1 multiplied by its relative abundance, then you add that one to the mass number of isotope 2 multiplied by its relative abundance, and all of them together divided by 100. If we check on this formula, there are those things that has been provided in the question. For example, if you check the question, the relative atomic mass is already provided, 6.94. Mass number of each isotope is also provided. For the first atom, it is lithium 6, so that is the mass number. So 6 is the mass number for isotope 1. Mass number of isotope 2 is 7. So what is not provided is the relative abundance, and that is actually what is needed in the question. So we put what is there, and so that we can know what is not there, how we can determine it. So then from there, we remember that relative abundances usually add up to 100. That is a very important point to note. Relative abundances usually add up to 100. So relative abundance of isotope 1 and relative abundance of isotope 2, both of them should add up to 100. In case lithium had 3 isotopes, just in case it had 3 isotopes, but you already can see we have 2 isotopes, but just in case it had 3, what we would have written in the formula is mass number of isotope 1 multiplied by the relative abundance, mass number of isotope 2, and also we go to the mass number of isotope 3, and all of them multiplied by their relative abundances. So the number of times you repeat about the isotope 1, the isotope 2, the isotope 3 is dependent on the question and how many atoms you are presented with. So let's begin the question, the interpretation, considering that major point that the relative abundances usually add up to 100. So here we begin the question. We say, like we do in mathematics, let the relative abundance we can choose any isotope. So we can say, for example, let the relative abundance of rhodium-7 be X. I have just said that the relative abundances usually add up to 100. So that is to mean that we can also let the relative abundance of rhodium-6 be 100 minus X, because both of them should add up to 100. Then we begin the question from how we have arranged the formula. So where we have RAM, we put 6.94, because in the question the relative atomic mass was already provided, 6.94. Then we got to isotope 1 that we have said is rhodium-7. So we say mass number is 7 multiplied by, we have just said that the relative abundance of rhodium-7 should be X. So multiplied by X. Then we put all of them into bracket plus, we got to mass number of isotope 2, which is 6, multiplied by the relative abundance of rhodium-6 is 100 minus X. Minus X. Then all of them together, we divide by 100. From there, we start removing the brackets. And by removing the brackets here, it is over 1. So we cross multiply. So we say 6.94 multiplied by 100 is equals to 7 times X, we get 7X, plus 6 times 100, 600. Then we have this plus and this minus. Mathematically, plus and minus become minus 6X. Then we put the like terms together. So, but first of all, we multiply these ones. It comes to 694. The decimal is already gone. It comes to 694 as a whole number is equals to 7 and 6x. We have x plus 600. Then we again put this one to the other side. So we say 694. This one is already positive, so when it goes to the other side it will be negative. Minus 600 is equals to x, because we had already put the x together. 7 minus 6x, it was already coming to x. So from there we say that x is equals to 694 minus 600, which is 94. From there, we remember what we had said up here, that let the relative abundance of rhodium-7 be x. So the x that we have got down here, is actually the relative abundance for lithium 7. So you will say relative abundance of lithium 7 is equals to 94. Remember, it is in the percentage form. What about lithium 6? Lithium 6, we said that the relative abundance should be 100 minus x. So it will be 100 minus x, which is 94, because x was 94, so minus 94, and then we get 6%. And why have we put 100 minus 94? It's because for lithium 6 it was 100 minus x. So you can actually even arrange it from that point of view. So you first of all say, so that you don't get confused where we are getting all these. Lithium 6, we have 100 minus x. So first of all, put the x. Then you say, in the determination of the value for x, that one was 94. So you say 100 minus 94, and then you get 6. Remember, it is in the percentage form. It is in the percentage form. So that is what was required for the question. So that is how you need to determine that question. I hope you can see all of it, and just in case you have any question in any area that you have not understood, I'm right here, just a comment away. So make sure that you comment and tell me where I can explain further. So in case you get the value of x and then you leave it at that, you will not get the answer mark. Again, if you write that for lithium 7 the answer is 94 without the percentage, you will not have followed the instruction, because the question was that you determine the relative abundance in a percentage form, and it usually is in a percentage form even in the other questions wherever you get them, unless otherwise stated. There is this other form of the questions for isotopes, and it is very necessary that you also tackle one of them, where we are determining the relative atomic mass of potassium, and the information is provided already. So let us do it from the formula. Relative atomic mass is equals to mass number of isotope 1 multiplied by the relative abundance. By now you know that I'm shortening the word relative abundance, but make sure that for you, you write it in full, added to the mass number of isotope 2, multiplied by the relative abundance. And unlike the question for lithium, where we only wrote up to that point, for this case we have 3 isotopes, so we will go to the extent of writing the other part about the isotope 3. So mass number of isotope 3 multiplied by the relative abundance. Again, put that one into bracket, and all of them together we divide by 100. So even in other question, if you get the isotopes being more than 2, maybe 3, maybe 4, like in this case, if we had another 4th potassium, we could still go to the mass number of isotope 4. So you go to the extent depending on the number of atoms that are provided. So let us put in the information. So we are determining RIM. For the first atom of potassium, the mass number is provided. So mass number here is 40 multiplied by the relative abundance 0.01. Put them into bracket. Then mass number 39 multiplied by 93.1. We go to the other one, 41 multiplied by 6.89. Again, you put them into bracket, all of them together, divide by 100. Let me remind you of something. From the definition of the term isotope, we wrote about atoms of the same element. So look here, it is the same element repeated all through, and all of them being different atoms but of the same element. That's why we have potassium everywhere. It is the same element, so atoms of the same element. In our case, the element is potassium. If you look at the atomic number, is 19 for the first one, 19 for the second one, 19 for the third one. So the same atomic number. So you see, there will be no need of writing it as atomic numbers, because it is just one atomic number but repeated severally. So with the same atomic number but different mass numbers. Look at this, 40, 39 and 41. So different mass numbers. That is why it is necessary that you write it in plural mass numbers. So atoms of the same element with the same atomic number but different mass numbers. So going back to the question, we remove the bracket. So RIM is equals to 40 times 0.01, we get 0.4 added to the next one, you get 30.9 added to 282.49, and all of them again you divide it with 100. And I hope you have your own calculator so that we can be on the same page, all of us. So I hope that is what you have in your calculator. So from there, we add all of them together. After we add them together, we get 3913.79. Again, divided with 100. The last answer will be, you divide by 100, so the decimal places go to the left 2 times, so 39.1379. And don't round off. The more the decimal places, the more accurate your answer is. So train yourself not to have the habit of rounding off now and then, just in case there will be somewhere where you round off and then you miss the mark for accuracy. So that is the answer. It usually does not have any units. It is just there as a number with no units. And then let me remind you of something that we said about the most abundant isotope. We had such a question as we began the lesson. So if you look at the 39.1379, and in case you were to be asked among the isotopes of this potassium, which one is the most abundant, we said that you usually check on the relative atomic mass. Then you look at the relative abundances that are provided. So you check on the relative atomic mass that you have got as the answer. Then you go to the relative abundances in the question. You see the biggest number there is 93.1, and then you check the mass number for that isotope, that is 39. So meaning when you round off the relative atomic mass that you have got in the answer to the nearest whole number, you are supposed to get 39. And if you look at the mass numbers provided in the question, 39 is falling to where we have the biggest relative abundance, the biggest number for the relative abundance. So that is 93.1%. So even when the relative abundances are not provided in the question, by just having the relative atomic mass and the mass numbers, you can tell which one is the most abundant. Check the relative atomic mass and the mass numbers provided. The one that is closer to the relative atomic mass, that is the isotope that is the most abundant. Finally, I say this, and this you can try with your calculator. I already said in a previous question that the relative abundances should add to 100. So you can try 0.01 plus 93.1 plus 6.89, and you see if they actually can add to 100. And that is one way of telling if the question provided for you in any question is actually correct. And then you can ask for a correction. If the relative abundances are not adding up to 100%, then you know that there is a problem with that question. So who knows, maybe one day in future you also become a teacher of chemistry. So you need to follow on to this information to the mark. So I'm really wishing you the very best. Keep on working hard. Hard work pays. This retro information here and there will build your knowledge in chemistry, and it will also give you a positive motivation towards working hard for a better grade in chemistry. So in case there is any other topic that is a challenge to you and you would wish us to tackle it, make sure that you ask it in the comment section. I wish you the very best. If you have not yet subscribed, kindly touch the subscription button. It is very free. Like, comment and share to so many other students, and make sure that you keep right here in this channel where we make chemistry very friendly for all our learners. I really appreciate your presence here. God bless you. Thank you.